Hi guys, today we are going to solve this question. Contains container with most water, that is lead code number 11, and it asks in the companies like Bloomberg. Okay, now let's understand what the problem is saying. So it's given a height of arrays. Okay, we are given with the okay. So we are given with an array. So yeah, this is the array we are given, and we have to find the max area in which most of the water should be present. Okay, so here is the diagram of it, and let's build intuition of this. So what we see from the graph is we can fill the water. Actually the question is, this is the height bars. Okay, we can think of it like what we can see is can it's a can water can, and what length we have to make, so that the lengths are already given. Okay, the heights are already given. So what we have to do is, in among which heights, between which heights the most of the water will accommodate or will be present. This is the thing what the question is saying about. So what we can do is, this is the two heights, right? Can we fill the water here? No, right? We can fill till here, because till this point the water remains inside this. When it start filling here, it will overflow. That's the thing. Okay, so we have to check that in among these two, the minimum of it, till the minimum we have to see, till the minimum it can hold the water between these two. And what about this? And let us check this red one and this one. Among these two, the water that can be present in this is till here, because this is the minimum point. If we fill after this, it will overflow, right? It will overflow. We cannot fill the water till here, right? Okay, if there was bigger than this, so this is the bigger, so we can fill it from here to here, right? This will be the area of the water, right? So we have to take the minimum. Okay, that's what we see have seen here. And what else we have to include is, and we have to find the area. Okay, we have to find the area of it. So what will be the area of a rectangle? Okay, so the area of a rectangle is basically length into breadth. Okay, so you can consider this as a breadth and this as a length, or length breadth into height, or whatever you're comfortable with, you can go with. As it is a 2D rectangle, for the formula is based for 2D rectangle. Okay, and let's see what is the length and breadth, how can we can find. Suppose we consider any 2 points. Let us consider for any 2 points first area of what, area of like what we have is, let us take this second index and we can take like fifth index. Okay, now let's calculate the area of it. Let us calculate the area of it. I will highlight that, okay, with yellow color. So till here we have to find the area, right? This is the water. First time you are seeing yellow color water, right? So now let's back to the question. We have to find the water area between 2 and 5. Okay, so you say me, what would be the length, what will be the, like, sorry, breadth and height, right? We have considered breadth and height. The area formula we write it here. Area is equals to breadth and height. So what is the breadth? We can say this is 1 2 3, that is breadth is 5 minus 2. Okay, we got the breadth. What is the height? What is the height? Okay, here's the question, here's the catch here. So the height of the second index is 6, and the height of this fifth index is hopefully 4. Let's check it. Yeah, 4. 4, right? No, 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 here. Yeah, 4. Yeah, it's 4. So Among these two heights, which one do you consider as our height to calculate the area? Okay, what we do is we have to select the minimum of among these two. Minimum height, minimum height, minimum height of 5 and second index and fifth index. So what is the height of second index is 6, and the fifth index height is 4. Now we have to take the minimum among these two, right? So what is the minimum of 6 and 4? It's 4, right? Yeah. So what we got, breadth here is 3, 5 minus 2 is 3, and our minimum height is 4. So we got the area as 12. So look at this. The area is 12 centimeter square. The area of this particular is 12 centimeter square. Hopefully it is in the centimeter if we consider. So the catch is we have to calculate the maximum area, okay, in which actually, like, we can say if we find the max area, so obviously the water will be more in the max area, right? So this is what we have to do. So max area, how to calculate the max area? We create a variable called max area, and we will be storing max. We calculate this area, and we have to calculate this area, and we'll compare with area, and then we have to find the max. Okay, let's come back to the institution of what approach we have to find in this. Okay, obviously the brute force which carry the okay, obviously brute force will go with the order of n square. So we have to think for the approach of order of n. So what we know is 2 pointers. Let us apply 2 pointers. 2 pointers. Yeah. So I'll mark a left pointer to the zeroth index, and I'll mark the right pointer to the last index, that is n minus 1. Okay. Now let's calculate the area of this 0 and 8. As we know, area, what is the area? What's the formula of area? That is breadth into height, right? Area is equal to breadth into height. Area is equals to breadth into height. And what is the breadth? What is the breadth is 1, 2, 3, 4, 5, 6, 7, 8. That is r minus l. Right? That is 8 minus 0. Breadth is r minus l. So what is the height? Height, what we have seen is minimum of these two. Minimum of these two. So we will call the minimum function, and we pass the height of L and height of R. Okay. We are done with the area formula. Now we have to just check. Okay. First, we create a max area variable in which we store the minimum value. Minimum value. Then we create a area is already present here. Then we start checking. So first area is 8 minus 0 into minimum of 8 comma 0 is what? What the minimum height is here, it is 1, and here it is 7. Minimum is 1. 8 into 1 is equal to 8. So this here the area is 8 centimeter square. Our max area will be updated to 8. Area is 8. Okay. The next is the now what we have to move, either left or right. So I can see here we have to check a condition. If left if the left the height of left is less than height of left less than height of r. Here's a catch. The condition plays a very important role. If the height of this one, this is one, you can see, right? If this is the height, this is the heights. Okay, this is 8, 6, this is 3, I think so. No, 2, right? 1862, 1862, 548, 548, 37. Okay, all right. 18654. It is okay. Now these are the heights, right? If height of L is less than height of R, yes, it's obviously one is less than R, right? Yes. So which one we have to move? Obviously, we move the left pointer because we are getting the less amount, right? Here we have a very big one, right? We'll change the pen color 1 second. Here we have a very big already a bar, or what we can say a bridge. Here we have a smaller bridge, but we want the max area. So to for finding the max area, we remain with the big bridge, or we have to remain with the small bridge. Obviously, you have to remain with the big bridge, and we have to find the other page which can be bigger than this bridge. Okay, if we got the big bridge has this, we can accommodate more area, right? More water, right? We get the more area, and we get obviously more water in that. So we have to move the pointer where the height of that particular pointer is less than the other pointer, other height. Okay, here what it is, left is small, so we have to move the left pointer. Then we have to again check the area for this. So this is the condition. I will be doing the condition part here. Okay, the area, now we have to calculate the area. So the area what we have is now 8 7, right? Okay, the 8 minus 1 into minimum of 8 comma 7 is 7. Okay, we got here is 8 minus 1 is 7, 7 7 is 49 centimeter square. Okay, now we have to check 8 is big or 7 is big. Obviously 7 is big, so I have to move the right pointers. Okay, now it's been updated, the 49, here it is 49 max. Okay, now what we have is we have to compare again, right? Compare again, that is 1, that is it remains 8. Okay, 8, no, wait, 7 minus this, we have to see the indexes when calculating the breadth, and we have to look for the height when calculating the height. So 7 minus 1, that is 6 into minimum of what? 3 and 8. Minimum of 3 and 8 is 3, obviously. 6 3 is 18. 18 is the area, so area will be 18. Okay, this is 14. Area will be 18, and we have to compare 18 and 49. 49 is greater, so max area stays 49. Okay, now calculate the next part. We have to calculate. Um, in this, we have to move the pointer. The right pointer obviously moves to this. We calculate 1 6 minus 1 into minimum of this is 6, height is 8, and this one height is what we have is like this is 8, and this is 8. Minimum of 8 and 8 is 8. 6 minus 1 is 5. 5 4 is 40. So the area will become 40, and again it will compare with this max value is still 49, so 49 remains, and we have to move the pointer. So here is the catch, we can move either of the pointers. Now we can move, if it is equal, we can move either of the pointers, either left or right. Either of the pointer you move, I will be moving left pointer. Okay, or if we have not specified the condition, always the else part will run, and the right pointer will be moved. When if we not specified the not equal to your symbol, then the else part will be run, and we have to in the else part what it is, r minus minus. So r minus minus will be happening when we don't specify the equal to symbol. If you specify the equal to symbol, then obviously left pointer will be moved. So either of the pointer we can move, it's not a problem. Okay, now getting back to the finding areas, what we have is 8 and 4, right? 8 and 4, 5 minus 1 is 4 4, and 8 and 4 is 4 4 4 is we have what? 16. Then again we have to move, our pointer will be moved. Then we have 4 minus 1 is 3. 4 minus 1 is 3 into what we have, the areas. 4 is the minimum, right? 4 is the minimum, no, 5. 3 5 the 15. Now move the area, obviously it will move. Okay, 2, here is the 2, and here is the 3 minus 1 2. 2 into 2 it is 4. Now the last area we are calculating, r will be moved, and 8 2 minus 1 is 1 into the maximum minimum among this 2 is 6. 1 into 6 is 6. So after this the left right, what is right moves here. Okay, we have given the condition that while left should be always less than right, so the condition breaks and it comes out of the loop. So what we have to return is maximum area. So as you can see guys, in this particular areas, among this area which is the maximum, 6 4 15 16 40 18 49 8, so you can see 49 is the maximum area what we have got. Okay, 49 is the maximum that we have to return. Now let's code and test the cases. So here we are with the environment, and let's start coding. What we have is, first we have to initialize the pointers, right? What you have to do is, first we have to initialize the pointer. L is equal to 0 and r is equals to height dot size minus 1. Okay, then we have is int, what we have is area, max area is equals to, first we have to initialize with int minimum most value. Then we have what, we have area, we have to calculate area inside. Let's calculate inside, run a while loop, and left should be always less than the right. And here we have to calculate the area. What we have seen is like r minus l, that is the breadth, star what is the minimum of height of l comma height of r. Yeah, this is what it is. And the next things are like, we have to cal we have to calculate the max area. We have to check max area is equal to max of max area comma area. Then we have to, this here the pointers logic begins. Pointers logic, two pointers logic. Okay, here if height of l is less than height of r, then we have to move l pointer, else right pointer. Okay, this is the thing. And we are at the end, we have to return max area. Hopefully it runs. Let's check it. So we are getting a wrong answer. Yes, where is the mistake? Yeah, r minus it's l, right? It should be in the bracket. Okay, r minus l. Okay, and minimum. Okay, max area. Fine. Now let's test it. Okay, we got the 49 as the output. Now let's submit this. Yeah, you have passed all the test cases. 65 by 65. Okay, hopefully you have understood the concept and intuition behind this. It is a question like it requires practice. It involves a two pointers approach along with a mathematical formula. Basic maths is required for solving this type of questions. And yeah, thank you.